screen. Now let me show you something. If you press Y equals, do you see how that's highlighted? Now for the graphic, that plot's highlighted. For the graphing that we're going to do today, we need that highlighted. But if you were going to do regular graphing, like we've been doing, it wouldn't work with that highlighted. So now you know how to undo it, right? If you go to do a regular graph, let's say your brother's going to use your calculator and they're graphing parabolas in Algebra 2, then they need to turn that plot off. And to turn it off, you do exactly what we did. We go to second stat, plot, and then we would just press enter, and then we would click over and highlight off. Now my plot's off. Okay? But, so, see how it's off now? But I need it on, so I'm going to turn it back on. So everybody's got your plot turned on, right? Okay. Now, let's look at the data points that we have been given. I even set them up in a T-chart, right? So let's let the first column be the X's and the second column be the Y's. And let's set our window to appropriately match the data points that we've been given. So my X's, it looks like, go from 1 to 6. So I like to give myself a little bit of wiggle room. So maybe I'll go from -2 to 8. That gives me a little bit of wiggle room on my X's. Now, is there anything scientific or exact about that? Could you set it something else? And as long as it contains the numbers 1 through 6, you're good. Okay, let's do the same thing with the Y's. Maybe for my Y's, I'll go from -5 to 90. Again, nothing magical about that. Okay, still with me? Okay, now I'm going to put in the data points. So to put in the data points, press Stat. You have a Stat button right here. Press Stat. See the options that you've got? Anytime that you are putting in data, you use Edit. So we're in Edit, so we just hit Enter. And it is going to throw up a column of, now yours might be blank. I've put stuff in my calculator before, so I've got data in there. Are yours blank? Yeah. Okay, then you just go ahead and start putting it in. Just enter in your X's here and your Y's here. Okay, to clear it, if you go back to your Stat menu and go down to Clear List, hit Enter. Now, I don't know if you noticed or not, but my lists were named L sub 1 and L sub 2. So I come down here and I have a button that says L sub 1. There's it, L sub 1, comma, L sub 2. And it's done. So now when I go back in, now my columns are clear. You can also just type the new data in on top of the old data. You can do that. So we're just going to fill those two columns with the data that was given in the problem. So 1, 2, 3, 4, 5, 6. And 1, 10. Make sure you hit Enter after the last one so that it actually shows up in the table. All right, so we got our data in. And I'll just quit. I'll just hit second quit. Now I'm going to hit Graph. And what did the calculator just do? It plotted the points that I put in my table. Now, at this point, you got to sit back and look at that for a minute, and you got to decide, for us right now, I'll deal with it later, for us right now, we are graphing lines and parabolas. That's all we're going to do. So you look at that and you tell me, does that look linear or does that look like a piece of a parabola? I think it looks like a piece of a parabola, don't you? Can't you see that arc right there like that? So now we're going to write the equation of that parabola. So here's what we do. We go back to our stat menu. And remember, we were here before and we used edit. What did I tell you we use edit for? To put in data. So when you want to build those tables, you use edit. We are going to do some math now. So we're going to click over to Calc. And we're going to go down to where it says Quadratic Regression. Now, does anybody have an idea why I'm choosing Quadratic Regression out of that whole list? Why am I picking quadratic? Delaney? Because it's a parabola. If I had looked at my data points and thought, oh, those are in a straight line, then I would be choosing linear regression. Now, there are tons of different kinds of regressions. We're just not ready all at once to swallow all that. So ours are either going to be lines or parabolas. So we think we've got a parabola. So I'm going to go ahead and hit enter. Now, it is asking me to tell it, okay, Lisa, you want me to do a quadratic regression. What data do you want me to use? I wanted to use the data that's in those two columns, right? L1 and L2. So I'm going to type L1, and L1 is right on your keyboard, kids. It's L1 is right here. It says L1. So just second L1, then you got a comma button, hit comma. All the buttons are right there for you. And then L2. And then what comes up on the screen, remember this is quadratic. This is what a quadratic looks like. So they tell me now that my equation is 2x squared plus 3x minus 4. Because A is 2, B is 3, and C is negative 4. What do you want me to do about that?
I'm just wondering, do you want me to like do this on my iPad, like one?
You can do anything you, whatever works for you. I don't care.
Okay.
But I need you to know how to do this.
Yeah,
so maybe she'll write it and you can copy hers or something. I don't know. I mean, make a photocopy.
Yeah. Okay.
Whatever works.
Okay.
Yeah.
So this is just.
But you can type with one hand, can't you?
Yeah, I can make a rep. Yeah.
Yeah. This is for your own use. And we're taking notes now.
Okay.
Okay, so we've got our equation. Now we're going to do another example, so if you didn't keep up that time, we'll go through it again. But this is where most of us should be, right here. So on the paper it says write the equation. That's what you get. Now it says, how many attentions will you receive if you are tardy 10 times? Well, what are you going to do with this equation now? You're going to plug 10 in for x. And we know we're putting it in for x because when we set up our t-chart, x was the times tardy, right? So we plug 10 in, and whatever we get, that's going to be our answer to that question. So it looks like 226 maybe? Now, let's turn the paper over, and let's start the process over from the beginning. So those of you that fell apart the first time, let's do it again. Here we go. Now, my stat is already turned on. My plot, is already turned on, so I don't need to worry about that. So how am I going to start? What am I going to do? I'm going to put in a new set of data, right? So I am going to go, where do I go to put in the data? Stat, and then edit, right? Now, I'm going to show you how to clear those out again, because now I've got the data in from the last problem. I can either type right over it, just type right over it, or I can clear it all out at one time. So for those of you that want to clear it all out at one time, you go to Stat, click down to where it says Clear List, type your L1, comma, L2, and hit enter. Now, all the data that I had in there is gone. But again, you can type right over it if that's easier for you. so now I'm ready to put this stuff in. So I'm putting in my x's. Okay, so I got my x's in. Now I'm going to put in my y's. Now before I graph, what do I need to remember to do? I got to change my window because I want to be looking at these data points. So this time, take a look at my x's. What might be a good range for my x's? -5 to 6. I'll use 8. 6 is fine. Nothing scientific or exact about this. My y's, -5 will be okay, and I only need to go up to what, about 50 this time? Take a look at those points. This one's a little easier to see, I think. Remember, we're only doing linear and quadratic regression. There are tons of other kinds of regressions. We just haven't studied those curves enough to do those yet. So would you say this is going to be linear or quadratic?
Quadratic.
This is definitely quadratic. So do you remember what to do? Because your job is to write the equation. This is the plot. So you could draw a picture of that in that little box there. But then what's that equation? How do we do that? We go back to Stat. And we click over to Calc. Remember, in the Stat menu, Edit is where you put stuff in. Once it's in there, you want to do something to it, then you're using the Calc menu. We'll click all the way down to Quadratic Regression. Then we tell it we want it to work on L1, column L1, and column L2. And this equation is 3x squared plus x minus 4. Is that okay with everybody? Okay, well, we want to do a couple other things. If we have time, we can come back and do another one. But right now, I want to finish the rest of the stuff that's on here and look at your factoring homework from last night. So let's go ahead. Let's just stay on the side we're on, the back side. And then we got some equations to solve. So this should be review. Okay, this one, can we solve this without a calculator? I think so. How would you do that? Gracie?
Would you like distribute it?
Absolutely, you would distribute it. And then what, Gracie?
Subtract 14.
Exactly. What kind of equation is this, groupies? It's a quadratic equation. And what do we always do with our quadratic equations? Set them equal to 0. Get them set equal to 0. If you wanted, last night's homework, there was just a little bit of factoring review. If you want to factor this and it factors, you can. I don't think that one factors, though. Does it? Mm-mm. So what are we going to do? You could do completing the square. I'm not going to because it's going to involve fractions, right? So I think we'll just use the quadratic formula. That seems the easiest way to me. So negative b plus or minus the square root of b squared minus 4ac. So let's see, what's that? 49 and 56. Is that 105?
Yeah.
that breaks down? No. So that would be the answer. Is that pretty easy? Now this one is a cube. So this is like the one on your test yesterday, right? This one we're going to graph. It says use your calculator. So we're going to graph this one. Now this is good practice for us because guess what? Let me just show you something. If you go ahead and put in this equation, which is what we would do if we were going to graph it, right? We go to y equals. This isn't data points. This is just a straight up equation. We're putting it in. All right, let's go ahead and put it in and press graph, and I want to show you what happens. So we put it in x cubed plus x plus 4, and I hit graph. Oh, shoot, it worked. I didn't think it was going to work. Now, the data points are still in there. So if I turn off my plot, those will get out, but I didn't think it was going to work at all, so that's awesome. Great, it worked. And I can leave that up there, it doesn't bother me a bit. What would I be looking for? I actually see what I need. The window's not perfect, but what would I be looking for? That point right there, right? So if you want to leave all that gunk in there, it doesn't hurt a thing. If you want to take it out, just turn off your plot. I didn't think it was going to work at all, so this is good news. Okay, so I will, how do I find that point? If I'm just going to leave everything up there, I'm not going to change anything. How do I find that point? Second calc. 0. Move my cursor so it's somewhere to the left. Then move it so it's somewhere to the right. And it looks like negative 1.38. Now, if you don't like the fact that it's all squished up down there, it's hard to see, plus it's got all those random dots up there, and it's really squished up, what could you do? Well, you could turn off the plot. That would get rid of the dots. And if you went to your window, what could I adjust in my window to make that a little bit better, maybe? Make the y a little bit smaller, so maybe negative 20. And then that opens up that graph a little bit. Gives me a little more room to work there. If you want to, it doesn't make a difference. Obviously, we got the answer. All right, let's turn it over, finish up the other side. These are just a couple of factoring problems. This is what you practiced last night. We'll go over them here in a minute. Okay, how does the first one factor?
2x minus y.
Now this is called the difference of squares. 2x minus y, 2x plus y?
Yeah.
Everybody okay with that? Remember how to factor the difference of squares? And then what's this one?
It's cubes.
This is the sum of cubes. Anybody remember how to factor the sum of cubes? At our PLC last week, Sister Mary Sue, who teaches calculus here, was telling us pre-cal teachers they don't know how to factor cubes. So we need to know this. This is important. How does that factor? Do you know?
Isn't it like 2x plus y?
It is exactly 2x plus y. So let's stop right there, Anna. You're right. I'll let you finish in a minute, but let's make sure everybody's clear on this. The sum and difference of cubes, and we can factor both the sum and the difference, is a little parentheses and then a bigger parentheses. In the little parentheses, we put 2x plus y. Now, does everybody see where the 2x and the y came from? Okay, so that's the first parentheses, the little one. Okay, Anna, now what goes in the big one? Do you remember?
Isn't it like 4x and there's a plus or
It'd
minus?
be 4x squared.
Yeah, 4x squared and then 2xy
It's going to be minus 2xy.
and y, or plus y squared.
Yep, plus y squared. You're exactly right. Now let's talk about the numbers, then we'll talk about the signs. This is this squared. This is this squared. And this middle term is these times each other. So to get this, she squared the first one. To get this, she multiplied them together. And to get that, she squared that one. Now, these signs will always match. So if this is a plus problem, that little parentheses will have a plus. This sign is always the opposite of this one. So if this had been a minus, that would be a plus. And that's always plus. This one never changes. It's always plus. So if we had 27 minus 8y cubed, we had a little, first of all, you got to recognize those are cubes. So we have little parentheses and a big parentheses. What's going to go in the little one? 3 minus 2y. Everybody okay with that? Now we start filling in the big one. So what did we say we were going to do? We're going to square that. We're going to times them together. And we're going to square that, right? Now this is a minus because the problem was a minus. This first parenthesis always matches the problem. Since that's a minus, this will be a plus, and that's always a plus. You good factoring your cubes? All right. Any questions about the factoring and the homework you had to do? 6. X squared plus 2xh plus h squared. It's a trinomial, so I'm going to try to set up a couple of little parentheses. What has to be in the front? When I do my foiling, big foiling, when you foil it, this times this has to give you that, right? So what's got to be here? X and X. Now, when I foil, this times this has to give me that. H and H. Now let's double check and make sure that gives us the middle term that we want. What do the outsides and the insides add up to? XH plus XH, 2XH. There it is.
Number 8.
X squared minus 3x plus 4. Plus 4?
Yeah.
Yeah. That's not going to factor. Because if it did, it'd have to be minus and minus. And my only choices are 2 and 2, and that's not going to give me the middle term that I want. The other choice would be 4 and 1, and that's not going to give me the middle term that I want. Now you can always check. If you are in doubt about whether something factors or not, do the discriminant. B squared minus 4AC is what? What's that equal? -7. If it's going to factor, your discriminant will be a perfect square. This is not a perfect square, so it doesn't
I
factor.
didn't think so. I just thought that it had the factor, but so it doesn't matter.
No, that's what's wrong with factoring. Things don't always factor, at least over the set of rational numbers. 10 is what we call quadratic form. In other words, it looks like a quadratic, but it's not a quadratic because its degree is 4. It's called a quartic equation, or expression. But it's in quadratic form, and what we mean by that is, okay, when we look at a quadratic, right, this is a quadratic. What's the relationship between this exponent and this exponent? Yeah, well, this is double that one. This is double that exponent. So that's exactly the relationship we have here. So we can treat this exactly the same as we would treat this. these are exactly the same kind of equation. Their graphs would be different and stuff, but they're exactly the same and can be handled the same. So if you had this, you would have no problem, I don't think, factoring it. This is exactly the same thing, only instead of x's, we have x squared. So it's going to be x squared plus 5 and x squared minus 4. Now, be careful, because this one actually factors 4. So you have to go ahead and factor that one by the difference of squares. So that would be your complete factorization. Okay? All right, let's look on page 81. This little section here at the beginning of the chapter, remember, this is where the guy who wrote the book really thought everything should start. This is the beginning. Let's look at problem 21. This whole little section is just full of a bunch of random things. So number 21 is actually a homework problem tonight, so I'm going to help you with it. So we got 12 by 12 squares, and we have 13-inch rounds. Okay, and we want to know which one is going to give us, or which one is the best deal. So how would you even think about answering that? What would be your idea, Lane? Find the area of this one. Okay, so what would be the area of those blocks? 444 square inches. All right, that's easy. They're 12 by 12 squares, so their area is 12 times 12. Okay, and then what would be the area of the 13-inch round ones? I believe it's probably diameter. So what's the formula for the area of the circle? Pi r squared. What's my radius? 6.5? 6.5. So my area will be 6.5 squared times pi. So let's see what that is. $132.7. So if you are interested in purchasing the best, or getting the most block for your money, you're going to choose the square ones? Okay, easy, easy, easy. Kids, these are not hard problems. They're just kind of random and weird. Let me look at another one. Okay, now 51, this isn't really a problem, except, I mean, it's kind of a problem. It's a problem with your calculator. So everybody look with me at 51. This is another homework problem I'm doing for you. And this is just one of the little pitfalls that we have sometimes when we use our calculators. I'm just making you aware of it. Let's go ahead and put in A on our calculator. We're just going to graph it. I'm on 51. I'm putting in A on my calculator. gonna start with a standard window. I have no idea, so let's just start with a standard window, because that's probably what we would do if we were just graphing. I pretty clearly see I have a 0 right here. Do you? All right, so let's find that one and be done with it. Because this is a little confusing to me over here. I'm not exactly sure what's going on. We're going to investigate that. But let's find the 0 that we're absolutely positive is there. So how do I do that again? Second calc. And I am looking for, okay, I don't know if you just saw it, my cursor just flashed by. So I'm going to set my bound down here. Oh gosh, I got -3. Oh, we need to talk about this. Some of you have asked me about this because it's happened on your calculator. See this right here? How many of you have seen that before? It's come up on your calculator and a little confused by that. That is scientific notation. So it means 2 times 10 to the -11. Tell me about that number. It's really, really, really small, right? In fact, it's so small that I'm going to interpret it as 0. So you can think of that as 0. Your calculator has a little bit of round-off error in it. It's trying to be as precise as possible. So it gives you this, but that's the same as 0. So anytime that comes up, you can think of it as 0. Okay, everybody good on that? Now I'm going to adjust my window because now I am, let me go back to the graph again. Now I am done looking at this part of the graph. I have found that 0, all is good. Now I'm really going to focus my energy right here. So I'm going to open that up a little bit and maybe set my x's from 0 to 2. I'm still a little confused, are you? Because what could be happening? It could be not touching at all, it could be just touching, or it could actually be dipping below. It's just really hard to tell. So now I'm going to adjust my y's and maybe try -1 to 1. Well, it looks pretty clearly now that it does at least touch, right? But what am I still not sure about? I don't know if it goes under or not. So let's go back and let's make our window. How about -0.01 to 0.01? Oh my. Now I see very clearly it goes below. I'm going to make it a little bit bigger because that was almost too much. Oh, see there? How many zeros are in there? 2. Now, if I want to locate them, they're very close together. And here's what's going to happen, kids. If you have 2 zeros that are very close together, when you set your bounds, they can only contain 1 0. If you accidentally or purposefully set your bound over here and told the calculator to find the 0, he's going to be all confused because there's 2 of them in there, right? So these are so close together, it's going to be hard for you to get those bounds set appropriately. So what do you think I'm going to do to my window now? I'm going to change the x's. Now, I don't need that wide, let me go back to my graph. I got way too much space here. So I'm going to get rid of that. And I'm going to go maybe on my x's from 1 to 1.2. Oh, now, does that make it a more manageable graph for me? This is an example of what's called hidden behavior. Hidden behavior is simply when you have a normal window, what should be a fine window, you can't really see what's going on truly with the graph. And so we have to mess with our window until we can see what's truly happening. Now, does that happen every time? Absolutely not. But once in a while it does. Okay? All right, now let's see. I had a couple more picked out. Let me look at them and make sure I'm ready with that. All right, what I want to do now is have you at your table, go ahead and look on page 81. Go ahead and work together with your calculators and do problem number 1. Do problem number 1. Did you get your calculator to work? So right now at your table, I want you to practice putting in data points, plotting them, and yeah. Yeah. Okay, so everybody should be, I should hear calculators clicking. Does anybody know why we even bother graphing these? What's the purpose of plotting these points? We doing it just because it's fun? Why do we plot them? What do we need to do that for? So that we know what kind of equation we're looking for, right? You could find a linear equation for any set of data, but would it be the best equation? Not if it's a parabola. So you got to know what kind of shape you're dealing with. That looks linear to me. I'm almost done.
Yeah. Or is it A?
I don't like that.
You have to change my window.
Mine looks linear. Does yours look linear? Yes. Okay, so how do we write the equation? It looks linear. How do we write the equation? Well, well, you can kind of look at it, but let's let the calculator do it for us. So we go back to stat, over to calc, and this time we're going down to linear regression. And I got y equals 2x. Now, just for fun, let's put in 2x in y equals, and you can graph your line right on top of your data point.
Just because she got the equation from the plot point and then she put it back into the, like, y equals and she graphed.
It's the graph.
What?
You guys are this I would like to do quad? No, that's not. No, really, no, oh, can you go ahead?
So I think
Oh, that one.
it must be.
And then how do you graph it over like that? And then just L1 and then just do 2x. Somebody interesting. That's so cool. Oh wait. It's deep. Right? It's deep. No, I just lost. Oh yeah, this is what we learned today. Precal.
Wait, what about
It's basically that I just said that. I am a passive right now. I'm so done. How was your game last night? Lost. Against who? How much? Oh. Who's your goalie? Sophie's out right now. Wow. She's so out. Yeah, she's done now. She can play out. Who's your goalie? Abby. We struggle.
It's not hard. It hurt my lower back.
So you guys start redoing better now? What? You start getting better?
Like running too much.
I don't lifting too much
If you girls don't figure it out, so then we
Have a good day. Okay, Jill, do your best with your broken hand.
I did actually. How did you plan it?
So, is it okay if